Okay, so in this video we're going to be looking at, continuing to look at, or returning I guess, to looking at graphs of sine and cosine, and this time we're going to add in the vertical translations. Just to start off, apologies if I sound a little stuffed up. I have what I hope is a sinus infection, but have had a COVID test just in case. Yeah, apologies if I'm a little blocked up. We just want to add in this final transformation. So we're pretty familiar with translating graphs up and down by now. So obviously y equals f of x, if we add a value onto that, goes up by c. If we were to subtract c, it would go down by c. Okay, so in this instance, adding c after the cos or the sine function, or subtracting c after the cos or the sine function, has the effect of translating up and down. The effect of c is to translate up down. I'll give more precise detail about that in the table down here. So yeah, let's just now summarise all our transformations. So we're now looking at 4 possible values in the sine or cos function. So a number out the front, which is about dilation from the x-axis, so that's going to change the amplitude of the graph. Similarly, if that value is negative, we'll get reflection in the x-axis. We also have n, which is about dilation in the y-axis, from the y-axis. So that's about changing the period of the graph. And again, if n is, that should say less than 0. We had that error on the other page as well. If n is less than 0, the graph is reflected in the y-axis, but we won't really see that happen. There are other ways to talk about those reflections. We've got plus or minus b inside the sine or cos curve. Okay, so that's the translation to the left or right. Remembering that adding a value within the function there moves to the left, subtracting a value moves it to the right. And finally, today we're adding in plus or minus c on the end, which is going to be about the sine or cos graph has been translated up or down, let's try that again, up or down by c units. For example, y equals sine of x plus 1 has gone up by 1. Y equals cos of x minus 2 down by 2. Okay, let's just work through sketching for graphs. So all the things we've already built up over our graph sketching are important. Identifying those amplitude and period changes, any horizontal translation, and then any vertical translation. We want to sort of think through scaling the axis in a sensible way. We want to think through range of the graph in this instance, now that we're going to start to move up or down. We also want to think about whether that means whether we'll have x-intercepts or not, and if we do have x-intercepts, we'll need to solve an equation to find those. So we're just going to work through 4 examples here, so let's have a look. So the first one, we want to sketch the graph of y equals negative 3 times sine of x plus 4. Okay, so the negative out the front allows us to think about the shape. It's a reflected sine graph, so it's going to go down first and then up. Okay, the 3 means the amplitude. Actually, I'm going to write period first just so that I can just sort of be a bit neater given what I want to do next. Period, there's no n value here, or n is 1, and so the period remains 2 pi. The amplitude has changed, that's the dilation from the x-axis by a factor of 3, so the amplitude is 3. And we also have a translation up by 4. So what I want us to now think about, now that we're going to start to move the graph up or down, is combining together the amplitude with the vertical translation to think about what that means for range. So if our graph has been translated up by 4, that now means that average or central value is at y equals 4, and the amplitude is now 3, so the graph is going to oscillate from 3 above 4 to 3 below 4. So for example, we're going to have y equals 4, and our graph is going to, it's going to go this way in this instance, but it's going to go 3 below 4, 3 above 4. So in terms of thinking about the range is going to go from 4 minus 3, which is 1, to 4 plus 3, which is 7. Okay. Okay, so we want to think that through, combining together amplitude and range. So the range is now going to be 1 to 7. We've also talked about using period and the horizontal translation to think about the scale. So the scale in this particular question, we just use a quarter of the period, so pi on 2 will be sufficient to mark all the key points that we want on this particular graph. Having identified the range also enables you to think about whether you will have any x-intercepts, because you won't always. And in this instance, we've translated the graph up by more than the range, and so the whole graph is sitting above the x-axis, and so therefore there won't be any x-intercepts. We want to sketch the graph from 0 to 2 pi, so we're going to see one complete sine curve. Alright, so let's think about axes. Oops. Okay, so let's make that 2 pi. Sorry, that's page 21 on the physical notes, so just get that out of the way so it doesn't confuse our axis. Alright, and then this is where I think it's more important than ever to think about those guidelines. So let's sort of just start by thinking 1, 2, 3, 4, 5, 6, 7. Okay, 7's important, 1's important, and 4's important. Okay, so this is where I really would get out my pencil and rule myself in some guidelines to help me with the shape. Okay. Alright, so my graph is now going to, it's a negative sine graph, so it starts here, no horizontal translation, so I don't need to worry about moving these points left or right once I've plotted them out. We're going to have the graph. It's a sine graph, so it finishes the period also at the central value, the average y value. There's also well, it's not an x-intercept anymore, but it'll be back at that average y value halfway along the period. Now, negative sine, so it's going to go down first, so we'll have a minimum value. Sorry, I did forget about actually scaling my axis in units of pi on 2. So we'll have a minimum at pi on 2 and a maximum at 3 pi on 2. Join the dots. So these graphs are nice and easy when we translate them high enough that they no longer hit the x-axis. Marking key points, so endpoints, turning points, so that's 2 pi 4, this will be 3 pi on 2, 7. That's actually not a key point, doesn't hurt to mark it, but it's not a turning point or an endpoint, so don't technically need to mark that one. But absolutely I would be marking it in terms of getting my shape drawn, but you don't need to actually label it with coordinates. This is pi on 2, 1. And then this is 0, 4. And there's my graph. Okay, let's have a look at the next one. Sketch the graph of y equals negative 5 cos of 3x plus 5. Okay, so again we've got that reflection in the x-axis, this time a cos curve. So the shape is going to start at the bottom and finish at the bottom. Okay, reflected cos curve. We've got our period change. There's a dilation by a third from the y-axis, so the period is 2 pi on 3, or a third of 2 pi, which means we're going to see 3 complete periods over that domain from 0 to 2 pi. We've got that our amplitude is 5, and we are translating up by 5. Okay, so these two things go together to enable us to think about range. So the range of the function, if we're translating up by 5, so y equals 5, and the amplitude is 5, then the range will go from 0 up to 10. Okay, so just delete those rough sketches. So 0 to 10, 5 below, so translating up by 5 gives us our average y value, and then we oscillate from 5 below 5 to 5 above 5, so that is 0 to 10. So we will have x-intercepts this time, but because it's literally going to be, the x-intercept will be the minimum turning points, again we shouldn't need an equation to find them. Good planning will let us mark out those points accurately. Okay, no horizontal translation, so we just want to think about a scale that is a quarter of 2 pi on 3, okay, so that's 2 pi on 12, so that's pi on 6. So if we use a scale of pi on 6, we should be able to mark all the key points that we need. Okay, let's draw our graph. So again, completely above or on the x-axis, so I can put my x-axis right down here at the bottom. I'm going to go all the way to 2 pi. but I want to scale my axis in units of pi on 6. So I'm going to mark out units of pi on 2 and then divide each of those into 3. Okay, so each of those ticks represents pi on 6. And therefore 2 pi on 3, which is the period, is at 4 pi on 6. So we're going to see one complete period there, one complete period there, one complete period there. Okay. Alright, let's mark in a scale on the y-axis. So we really just need to go to 5 and then to 10. So again, thinking about consistency of your y-axis scale to help you get the shape right. If you get this really skewed, if your middle value is not actually in the middle, you'll have real trouble getting the shape right. Okay, so I've just ruled in my guidelines. Okay, so upside down cos graph, which means it's going to start at the minimum at the start of the period. So that's going to be down here at the origin. At the end of the period, which we've already said is 2 pi on 3 or 4 pi on 6, will also be at this minimum value. Halfway along that period, which is either 2 pi on 6 or pi on 3, is where we'll be at the maximum value. And then halfway between the min and the max, which in this case is pi on 6, that's where we'll cross that average value. Okay. And so now we should be able to follow the pattern. Every time we move across by pi on 6, we get to the next key point. So across by pi on 6, I'm at the middle. Across another pi on 6, I'm at the maximum. Across another pi on 6, I'm at the middle. Across another pi on 6 minimum. So it's the next period. Repeat. And now we've got all the key points that enable us to draw in our graph. Now again, remembering that's a turning point at the bottom there, so make sure that your graph doesn't just sort of zoom straight out of here. You want to get the sense that you've got to turn, and again, you know, stop if you need, do them one section at a time, that's fine. It doesn't need to be perfection, but let's try that again. But if you've got all your points scaled sensibly, you should be, and again at the end there, turning point at the end there, so make sure you don't just launch straight into that end point. Okay, end point there is 2 pi 0, end point here is 0, 0. X-intercepts, again, we can just do by counting. 1, 2, 3, 4 pi on 6, which is 2 pi on 3. So it's 4 pi on 6, 5, 6, 7, 8 pi on 6, which is 4 pi on 3. Okay. Again, we can count for those maximum turning points. 1, 2 pi on 6, so that's pi on 3. So pi on 3, what's our maximum? 10, sorry. This is happening at pi 10. And then that is going to be 5 pi on 3. 10. Again, these points, not technically key points, they're not x-intercepts, they're not endpoints, they're not turning points, they don't need to be marked, but obviously they're important in terms of getting your shape right to actually sort of at least plot them, even if you don't label them. Okay, so there's my graph. Alright, let's have a go at another one. So 2 times cos of 2x minus 1. Okay, so shape, it's a non-reflected cos graph, so it's going to start at the top and finish at the top. We've got a period change. Period is being dilated by half from the y-axis, so that's 2 pi on 2, so the period is pi. We're drawing the graph from negative pi to pi, that means we'll see 2 complete periods. What else have we got? Amplitude here is 2, and we're going down by 1. Okay, so again, thinking of combining this information together to think about range. So down by 1, the centre of the graph will be at y equals negative 1. The amplitude is 2, so we're going to go from 2 below negative 1 to 2 above negative 1. Okay, so that means our range is going to be negative 1 minus 2, which is negative 3, negative 1 plus 2, which is positive 1. And so we see here that our range is crossing the x-axis, and therefore we're going to need to calculate some x-intercepts. Now I haven't left us a lot of space here, apologies, so perhaps draw a little bit small. I'll move myself over onto the side here, but yeah, perhaps make sure you give yourself some room to solve the equation as well. Again, thinking about quarter of the period is a useful scale, period being pi. In this case, we'll use the scale of pi on 4, so we can mark all our key points. Okay, so let's draw our axes. I'll draw them over here so I've got room to solve that equation under there. So, let's So we need our x-axis in the middle, and our y-axis, actually, sorry, I'm just going to move that. Sorry, I meant our y-axis in the middle. Our x-axis can be slightly up because the range is more negative than positive. So, for example, axes like these. So if we make that positive 1, that's therefore negative 1, negative 2, negative 3. I find students quite often get their axis, their vertical scale out of whack when they have to cross the axis. Please try and keep the distance between each of those ticks about the same. Otherwise, again, you'll have real trouble getting your graph drawn accurately. You'll find you end up you're skewing it to get it to fit your skewed scale, essentially. Alright, so pi on 2, pi on 4. Alright, minus pi on 4, minus pi on 2, minus 3 pi on 4, minus pi. Okay, again, I'm going to rule in some guidelines to help me get my graph shape right. That's going to be my maximum value, my average value there. Let's just get that a bit straighter. And my minimum value. Okay, so again, thinking about this distance should be the same as this distance. If it's not, your shape is going to really suffer. Okay, so good planning, careful planning will result ultimately in a better graph. Okay, so what have we got? Period is, so our shape, okay, just get one period drawn correctly, sorry, let's get rid of that. So let's just focus on the period between 0 and pi, so it's not a reflected cos graph, so it's going to start at the maximum value at the start of the period, finish at the maximum value at the end of the period, minimum value halfway along the period, average value halfway between there. So there's one complete period. We're now seeing, every pi on 4 across. We see the next key point. So move back another pi on 4, we're at the central value, back another pi on 4 down at the minimum, back another pi on 4 at the average, and back another pi on 4 at the maximum. So there we've plotted out our key points. Now we can see that we're going to cross the x-axis somewhere between here and here, for example. So you might choose to calculate those points first, or you can probably draw your graph in by eye at this point and then just label them. But you just want to be careful that you don't get them too badly in the wrong position. But I'm pretty confident that I can draw it and then label later. Oops, sorry. But either way, try again. Again, making sure you get a turning point out at the beginning there. Making sure again you've got some symmetry. The way that x-intercept, the solutions to the trig equations work, those distances are going to be the same. So make sure that you've kind of got that happening. And again, it should be, same sort of distance over here, my next x-intercept, etc. Sorry, let me just fix that. Alright. And same sort of distance past that marker there. Let's mark on the points I know, so that's pi 1, that's 0, 1, that's minus pi 1. This is pi on 2, negative 3, and, negative pi on 2, sorry, let's fix that. Negative pi on 2, negative 3. This is pi on 2, negative 3. Alright, and then we just need to calculate those x-intercepts. So the other advantage of solving an equation to find x-intercepts is you can see how many there will be. I can also see that there's symmetry here, and the two negative x-intercepts will be just the same values as the two positive ones. So I could probably just solve the equation between 0 and pi, and then use the symmetry to find the other two. Okay, so for the x-intercepts, okay, we're going to need to let y equal 0. And now we're solving a trig equation. So first thing is to get the cos part of the function on its own. So let's add 1 and divide by 2. So we'll get cos of 2x equals a half. And then we need to think through exact values, quadrants, etc. for our unit circle. So cos is positive, it equals positive a half. So definitely be in our first and fourth quadrants. Thinking through my exact values, half the equilateral triangle. This is 2, this is 1. So if it's cos, this is going to have to be the adjacent side, so we must be talking about this angle here, so pi on 3. So we're looking at pi on 3 in the first and fourth quadrants. Now again, I could think really carefully about my domain, and I know that I need my final answers to all between negative pi and pi, therefore I need my answers for 2x to be between negative 2 pi and 2 pi, but I'm just going to find them between 0 and 2 pi, so that I've got the final answers between 0 and pi, and then I'm going to use the symmetry of the graph to find the other ones. So just doing one lap of my unit circle from 0 around to 2 pi means I'm going to get pi on 3 and 2 pi minus pi on 3. So that means that 2x is equal to pi on 3, and 2 pi minus pi on 3 is 6 pi on 3 minus 1 pi on 3, so 5 pi on 3. And then dividing by 2, x is pi on 6 and 5 pi on 6. And so then the two negative ones are clearly negative pi on 6 and negative 5 pi on 6. Okay, so you should be able to kind of think that through. Okay, so let's complete our graph. So this is 5 pi on 6, 0. This is pi on 6, 0. This is clearly minus pi on 6, 0. And this is minus 5 pi on 6, 0. Okay, right, let's have a look at one more. So here we're going to do both translations. So let's think through everything about our graph again. So we've got our shape is a reflected sine graph, so it's going to go down first and then up. We've got translation, period is unchanged, so period is going to be 2 pi. We're going to the left, left by pi on 6. So I'll put those two things together to think about my scale. We've got an amplitude of 2, and we're going up by 1. So I'll put those two things together to think about our range. Okay, so these two things, the scale, this bit would mean we need a quarter of 2 pi. So 2 pi on 4 is pi on 2. And this we need pi on 6. And so those two things together mean a scale of pi on 6 will be sufficient. These two things together tell me about my range. If we go up 1 with an amplitude of 2, 1 minus 2 is minus 1, 1 plus 2 is 3. So the range will be from negative 1 to 3, so we will cross the x-axis. Period is still 2 pi, domain is 0 to 2 pi, so we're going to see one complete period, but because of the horizontal translation, it won't be a nice perfect period. It might, for example, start here and then, finish here as well. Okay, let's plot things out and then we'll focus on finding those x-intercepts. Okay, so 0 to 2 pi, what's our range? I'm just thinking about my axes. So, more positive axis than negative, but we do need a bit of both. 0 to 2 pi, we want a scale of pi on 6. So let's halve that. Let's halve again. So they're each pi on 2. And then if we divide each of those into 3, we'll now have sixths. Okay. Negative 1 and then positive 1, same above, positive 2, positive 3. Okay, again, let's draw in some guidelines here to help us. Got a bit wonky, let's try that again. If you've got a ruler or the edge of your CAS or something to get a straight line, good idea. Okay, so that's 1, looks like 2, try that again. That's 1 and that's 3. Okay, so again, when we think back to our translations left and right, I like to mark out one complete period without the translation to the left or right, and then we'll make the change. So I'm going to mark these points in blue here. So negative sign, so it's going to start at the central value, which is there, end of the period, which is 2 pi, which would be there, okay. Center of the period will be here, negative sign, so we're going to have minimum there and maximum there. Okay, that's without the translation. We're now going to take this graph and translate it to the left by pi on 6. So thinking about each of these ticks as pi on 6, that means this point's going to come off the scale and be over here. So we won't actually draw that, but I'm just going to plot it. Helps me get the shape right. This point's going to go here, this point's going to go here, this one goes here, and this one goes here. Okay, so again, we want to think about now. I'm going to do some calculation before I draw in here, because if I draw this, where does my y-intercept happen? Is it positive? Is it negative? Is it actually at 0? Okay. And I'm also going to calculate my x-intercepts too, just so I can be clear about, do I actually want to hit that point there? Does it cross somewhere here? Where should it actually cross? Okay, so let's calculate the y-intercept. That'll also give us the endpoint, and then let's calculate the x-intercepts before we actually plot out the graph. Okay, so the y-intercept, we let x equal 0, so we have y equals minus 2 times sine of pi on 6 plus 1. Okay, so sine of pi on 6, thinking about our exact values, this is pi on 6 up here. Sine is the opposite, which is 1, over the hypotenuse, which is 2. So sine of pi on 6 is a half. So we've got negative 2 times a half plus 1. Negative 2 times a half is negative 1 plus 1. So it does actually cross through 0. Okay, so my graph should actually cross through 0 here. And therefore, at 2 pi, the end of the period, it will also be at 0. Okay, let's calculate our x-intercepts. Just do that a bit over here. So let's make y equals 0. So negative 2 times sine of x plus pi on 6 plus 1. Okay, let's get the sine on its own. So let's take away 1 and divide by negative 2. So it's going to be sine of x plus pi on 6 equals positive half. Okay, we've got our exact value happening up there. We already know that sine's equal to a half when the angle is pi on 6. And we know sine is positive, so in terms of our unit circle, that's first and second quadrants. So solutions are to do with pi on 6 in the first and second quadrants. Again, once you get, I don't worry so much about the domain when I'm finding x-intercepts. I mean, you can, and it's a good thing to do. But if you're missing one or missing a couple, you can usually use the symmetry or the pattern on the graph to find the missing ones once you've got a couple of them. Okay. So technically speaking, I should be looking at a domain from pi on 6 around to pi on 6. So actually so what I mean by that is I should actually start here and then go around to here. But that way actually won't make any difference to me just doing one lap from 0 to 2 pi in this particular instance. I'll still get the same two solutions. So I'm going to have that solution there at pi on 6 and this solution here at 5 pi on 6. So x plus pi on 6 is equal to pi on 6, 5 pi on 6. Now I can see that when I draw this graph, my first x-intercept is going to be that one at 0. I already know that. My next x-intercept is going to be somewhere over here. And then there won't be another one, they'll be back at 0 again. So I've got enough here. I've got all the intercepts that I need. Technically there is the next one. There is also 2 pi plus pi on 6, so that's 13 pi on 6. But that's pretty much, that's just using the fact that the y-intercept is the same as the endpoint. That's just calculating that x-intercept and that x-intercept. So it wouldn't matter if I'd left that one out. Subtracting pi on 6 from each of these, I get 0, which I already knew. I get 4 pi on 6, which will simplify to 2 pi on 3. And I get 12 pi, sorry, let's try writing that again. 12 pi on 6, which I know will simplify to 2 pi. So I've just got those three x-intercepts, 0 and 2 pi I already knew about. And the next one is 2 pi on 3, which is 4 pi on 6. So that is going to cross through that point on my scale. Alright, so I should be able to... Now the other thing actually you could have done here is once you'd worked out that the y-intercept was at 0 and so the x-intercept, there was also an x-intercept at 0, actually the symmetry of the graph would have told us where to put the next x-intercept, and we probably could have avoided solving an equation here. So I would know that if the distance between the turning point and the x-intercept at 0 has to be the same as the distance between the turning point and that next x-intercept. So I probably actually could have avoided solving an equation if I'd wanted to. Now this x-intercept at the end here, that's not a turning point, okay? Same with this one here. The turning point's happening down over there. So again, making sure you're thinking about shape. Your graph shouldn't be turning into this endpoint, okay? It is just cutting through the graph at that point. Okay, let's mark everything we need. So 0, 0, x and y intercept, 2 pi on 6, which is pi on 3, negative 1 is that minimum, 4 pi on 6, which is 2 pi on 3, 0 is that x-intercept. Remembering this point's not a key feature, it's not an x-intercept or an endpoint, so that's fine. maximum here, again we can keep counting, and we've got 4, 5, 6, 7, 8 pi on 6, which is 4 pi on 3. And then my final x-intercept we know is at 2 pi 0. And so we've got all of our key points. Just a quick note if you're using your CAS to solve trig graphs. So, let's say, for example, I'm going to go to the scratch pad, press scratch pad again to open a graph. Let's just say I sketch something as simple as sine of x. You can have a play around with this. But I guess one of the problems we get is that a sine or a cos graph, we often need the x-axis scaled in terms of pi for those x-intercepts to make sense. Let me just also adjust my max and min y values just so I can see the graph a bit more clearly. So we can see that the x-intercepts aren't aligning. When the x scale is counting up in ones, obviously the x-intercepts are happening at places like pi and 2 pi and pi on 6 and whatever it might be. So they're not aligning with the scale on the axis. So you can change your scale in the same way that you adjust your window. You could do it through menu 4.1, or you can literally just click on that number once and then twice, and you could make it, pi on 6 if you want. And then you're seeing a clearer scale of what's happening. There is a zoom trig button. I'm not sure whether it will do what I want it to do now that I've already changed the scale, but if you use menu 4.8, I don't often recommend the zooms. Zoom trig used to be helpful because it used to rescale the axis in terms of pi, but it now doesn't. So it makes the ends 2 pi and negative 2 pi, but it doesn't actually give you a sensible scale happening here. So I would suggest that you just adjust manually as usual. Work today is from exercise 14J, again sketching some more graphs, combining that together with the solving of your equations.